Okay, click them closed. You're going to be using them though, so keep them handy. So the goal today, what I want to do, I really want to see if I can finish this. So you've got to give it a full day tomorrow to work your questions answered and finish working on stuff. So let's have like earbuds, phones, all that stuff needs to be away. I want to go through some problems. There would be a couple of problems from the first half of the chapter, but most of these would be problems from the second half. I don't feel like I need to review that stuff as much though, because that's what you've been doing. Thank you. But the thing I really want to show you is how to use this Desmos scientific calculator to check stuff. That's huge. I mean, that's something that goes well beyond this little classroom. That's going to help you on SAT tests, standardized tests, the SBAC test. Standardized tests more and more are going to using an embedded Desmos calculator rather than trying to invent their own, because it works so well. People are familiar with it. So knowing how to use this thing well will really pay dividends down the road, and it'll help you a ton in here also. Okay, so here's a problem this is where we left off yesterday, right? We evaluated this expression, and now I wanted to show you, and you're going to like this a lot. I'm going to show you how you can use this little Desmos scientific calculator to check this. Okay, what's nice about this is I can take this expression up here and I can type it out with X's and Y's. Make it look just like that. So I'm going to use my absolute value button there. I've got 17 minus 5x inside the absolute value, so I'll scoot to the right to get out of the absolute value and do plus 4 squared divided by, so it sticks it on the bottom, y. Okay, look good? Okay, and now if I hit enter to go down to the next line, I can define the variables. Okay, I can type in the values that I want to input. So I can input 5 for x. I just type x equals 5. Go down to the next line and I type y equals 8. And look what it does. See what it did? It went back. So the line where I entered this expression using variables, when I assign values to those variables, then it literally gives you the value of that expression when x equals 5 and y equals 8. That's pretty big, right? Okay, so we got it right. I'm going to take pictures of these so I can leave them in the notes. All right. So how about something like this? Solving an algebraic expression. Very simple. It's algebraic expression because it has variables in it. I'm not solving, sorry, I'm simplifying an algebraic expression. So if I'm simplifying, I'm not solving here, right? I can't, if people sometimes they want to put like x equals something, you can't do that. There's no equation here, right? I can't isolate x. All I'm doing when I'm simplifying is writing it in the simplest form. What are the couple of steps I'm going to do here? Distribute, good. I can distribute the 4 and get 5 plus 24x plus what, 12? And then last step, combine like terms. So I get 24x plus what, 17? Okay, so how do I check this? The way I can check this, especially now with this new feature in Desmos where you can put in values of variables, all I'm going to do is I'm going to enter this expression in one line, I'm going to enter my final expression in one line, and then see if I get the same value when I plug in values of x. If I do, then I did it right. Right? I mean, as long as you have to know enough to realize that you have to simplify this, right? Get it in its simplest form. But once I've gotten it into its simplest form, just to make sure I didn't make some algebra mistake along the way, if I'm still getting the same value of this expression before and after, I didn't make any algebra mistakes then. It stayed the same, it's just simpler. So in Desmos, it would just look like this. So I'm going to do before, I had 5 plus 4 times the quantity 6x plus 3. After, I had 24x plus 17. And let's just try that for x equals, throw out a number. 17. It works. Right? And if I really want to be very particular about this, I could say, okay, it worked for 17. How about if I try it for one more? If I try it for 8, it still works, right? So I did it right. Everybody see that? Because I'm getting the same value for both. I'm getting the same value for both expressions. That's a really good way to check it. Okay. Get a picture. Okay, let's move on to a little harder one here. That's too easy. We'll just save it. How do I do this one? Yeah, how am I going to do this? If I'm trying to solve this, and the whole point I put this on here, this is the easiest problem on the whole test. There's really almost nothing to do here. I don't have to do anything fancy like clear fractions. If I've got a proportion, if I have a single fraction equal to a single fraction, how do I always solve those? Cross multiply. That's it, right? Very simple. So when I cross multiply, I'm going to have this cross product, so 7 times 5x plus 6, so 7 times the quantity 5x plus 6 equals that cross product, 1 times 5x plus 7, and now I just distribute the 7 and solve. Right? Okay, no big deal. What about, okay, let's do this one real quick. This is pretty easy one, quick one. What am I going to do here? It looks like a mess right now, but I can clean things up a little bit. How? Distribute. Good, I can distribute the 4, I can distribute the -2. That gives me 12z plus 32 minus 20z equals, how about over here? Good. Plus, there you go. Negative times negative is positive, so plus 6, plus 30. I could combine like terms. 12z minus 20z gives me negative 8z plus 32 equals negative 8z plus 36. Good. Okay, now what? Well, we're solving in this one, right? Yeah, I can.
No solution.
Okay, how are you getting that?
Because they're both negative 8.
Okay, so when I try to move the variables to one side or the other, Zach, why don't you close that up? When I'm trying to move the variables, they all go away. I add 8z to both sides and the variables disappear. And then look at the result. The result is I get 32 equals 36, which is false, right? That's false, and so the answer is no solution, right? Whenever the variables go away and I get a false statement, we always conclude that means no solution. What happens if I get the variables disappear and I get a true statement? All reals. Now that could be an equation or it could be an inequality, right? But you might see examples where the variables disappear and I get something like 4 is greater than 1. That's true, right? So that still means all reals, okay? That's false, so no real solutions. Okay? All right, so, okay, this probably is a good one to look at. This is, I'd say this is one of the, this is one of the harder ones that we've done, just because we're dealing with so many fractions. And I just want to remind you one last time here about the kind of tricky ways to do this. So, what do we do with this guy?
Find least common denominator.
Okay, find the least common denominator. So to find that, we're probably going to look at the multiples of which number? 24, because that's the biggest and the most, the hardest to deal with, right? The biggest denominator. So we'll make a list maybe of the multiples of 24. So I get 24, 2 times 24 is 3 times 24, 72. And we can keep going if we need to, but let's just see if that's enough, maybe, right? So let's cross them off as we go. Well, does 24 work? No. 9 doesn't go into it, 18 doesn't go into it. What about 48? No, doesn't work, does it? 72.
Yes.
That works. Okay, so that's our winner. 72 is the number we're going to distribute through both sides. So I'm going to write it this way, right? I'm going to distribute a 72 to both sides of the equation. So I want to put everything on the left side in brackets, multiply 72 through everything on the right in brackets, and distribute a 72. Okay, here's the part I want you to, I feel like this was a lot of information the first time I gave this to you. But now you've worked with this stuff a little bit. I want to go back and just make sure everybody sees this simple way of doing this. We can just power through this if we want to. When I distribute the 72, for example, to the first fraction, if I look at that product, 72 over 1 times 5/18, what are my options? I could multiply straight across and get 360 over 18. That's a pretty horrible fraction though, right, to reduce. I mean, we could whittle away at it and reduce it, but it's kind of a lot of work to do that, or more work at least, right? What could we do instead? We could, say it again?
Multiply these numbers and divide by the
Divide by, well, okay, no, that's not what I'm looking for. We're not, so I think what you're thinking here maybe is that we've got, I know you're thinking that this is an equation, and we're cross multiplying, right? But it's not an equation, it's just a product, but we can still do something like that. When we have a product of fractions, instead of cross multiplying, we can cross cancel, right? So as I'm multiplying these across, what could I cross cancel here? How about the 72 and the 18? Right, 18 goes into 72 how many times? 4 times. So I could reduce that to a 4 and a 1, right? Is that an accident? Did we just get lucky? No, it's going to do that every time. How come? Because we picked 72 on purpose, right? Because all the denominators divide evenly into it, right? So this brings us back to that trick I was showing you guys before, right? All we've got to do here is when we distribute, we always know we're going to be able to cross cancel first and reduce. So do that. It's way easier. 72 divided by 18 is 4. So that's what's left to multiply by the top. I know I'm getting 1s on the bottom, right? And so 4 times 5 is going to give me my 20, and then I've got to be there, right? So 72 divided by 24 is what? 24 goes into 72 how many times? 3. So that's what happens when I cross cancel. 3 times 5 is plus 15. How much? That's way easier, right? How about over here? 72 over 3 becomes 24, which is what's left over to multiply by the top. So I get a 24b. 72 over 9, 8 times 2, 16. Now it's easy. Right? Now it's easy. Okay. So if we just, I guess let's quickly finish this one up. Where am I pushing the variables? To the right. Good. So the numbers go to the left. Those are gone. Those are gone. And I get -1 equals 4b. So what's my answer? Good. I'm going to divide both sides by 4. And so I get the answer, b equals -1/4. Right? Okay, let's try that. Let's check that in our original equation. And let's go ahead and use our Desmos calculator to do that. So you tell me, what am I going to do in Desmos now? Good. Okay, I'm gonna write whatever's on the left side. So that expression, so I've got 5/18 V plus 5/24. Right side, I've got 1/3 V plus 2/9. And what value am I plugging in for V? V equals -1/4. And look what happens. The left side of the equation and the right side give me back the same values. Those are pretty ugly decimals, but I know that I can convert them to fractions because it gives me the button. So I get 5/36 on both sides. Okay, so it works. Everybody see that? Okay, when I plug the answer back into both sides, I get the same number, so they are equal, and so V is the solution. There it is. All right, so, I don't want to spend a lot of time on this one, but if we're solving for the indicated variable, so we're solving for h, there's h, right? So what am I going to do this time? I got to isolate the h, good. So what do I do to isolate that h? What are my steps? Good. And if I'm ever unsure, remember I use inverse operations if I'm isolating. So first I've got to undo any addition or subtraction. What's that mean? Good. Subtract my 2 pi r squared. Those go away. I get a minus 2 pi r squared equals 2 pi hr. Okay, last step then. Good, divide by 2 pi r. Cancels the 2, cancels the pi, cancels the r. And I get my h by itself, so there's my answer. Okay? Good, good. That one's a little harder to check. Do you want to go through one of these?
Nope.
I'm seeing some people saying yes, so I think we want to do a quick one. I think that's a good idea. So it wants the numbers, two numbers, right? One number is 25 more than twice another number. So let's define our variables. So we got first number, we'll call it, and second number. So let's think of this in terms of what we're going to call first number and second number. The first number is 25 more than twice the second number. Okay, so which one are we going to call x? Probably the second number, right? Because the second number, they don't tell us anything about it, so we'll call that x. Well, if that's x, then the first number is 25 more than twice the second number. So how would I say that? Almost. Then twice the second number. There you go. 2x plus 25. Okay, good. And then it tells us up here that the sum of the numbers is 37. So how do I say the sum of the numbers? Okay, good. So x plus 2x plus 25 means equals 37. There's my equation, right? I can use to solve for x. And then once I solve for x, how do I find the values of the numbers? Plug them in, right? Make sense? Yeah. Okay? Okay, we'll leave it there. You could, from there, it's no big deal. That's an easy equation to solve. I want to get on to some other stuff. I'm going to skip that one. You know what? I'm going to skip that one too. Let's do this guy. How about? Okay. So if I'm solving an absolute value equation, what do I do to solve an absolute value equation?
Isolate the absolute value.
Isolate the absolute value. Good. So the first thing we're gonna do is divide each side through by 2. And that's gonna cancel the 2's, and I'm gonna get the absolute value of 10x minus 12 equals, so if I split that common denominator up into 2 separate fractions and reduce, what do I get when I divide 2 into each of those terms?
10x plus 4.
10x for the first one and 4 for the second. Good. So now, how do we, we isolated the absolute value. Here's the important step.
You make 2 separate equations.
2 separate equations. So whatever's inside the absolute values has to equal what?
The negative and the positive.
Negative and the positive. So it's going to equal what's outside or what's inside the absolute values equals negative what's outside. So negative the quantity 10x plus 4. Right? And then if we solve these, I'm just gonna, well, this one over here is kind of weird. The 10x is canceled, don't they? Right, in this first equation, when I subtract 10x from both sides, they go away, and I get the answer negative 12 equals 4. So what's the solution to the first equation again? No solution, right? How about the second one? I'll distribute the negative, and I'll get 10x minus 12 equals negative 10x minus 4. Okay, good, push the x's left, I heard it, so I'll add 10x, and I'll add 12 to push the numbers the other way. And we get 20x equals 8, so good. We divide by 20, and we finally get x equals 8 over 20, which would reduce to what? I could divide 4 into both of those, couldn't I? 4 goes into the top. No. 2 times. 4 goes into the bottom. 5. There we go. So I get x equals 2/5. Now, can I guarantee that's a solution, though? No, I can't. Especially if I've got variables on both sides to start with, right? So I got to go back and check it. So how do I check an absolute value function? It's easy. I just use absolute value in Desmos. Okay, so we'll try. So my expression on the left is 2 times the absolute value. There it is, absolute value of 10x minus 12. On the right, I just get 20x plus 8. And I'm checking this for x equals 2/5. Did it work? It did, right? So we only get one solution this time, and it was 2/5. Okay. Yeah, we're getting closer. So let's look at this one. So I want to show you. Okay, pay close attention to this because we got an inequality here. You might be thinking, well, how in the world am I going to use Desmos to check an inequality? There is a way to do this. There's a way to do this that's not that hard to do, and it'll make sense when we go through it once. So what do I have to do to solve this one? Distribute. So I distribute to 3. That gives me 9a minus 21 minus 6a is less than or equal to, if I distribute to 5, there we go, good. So I could combine 9a minus 6a, 3a, good, minus 21 is less than or equal to 5a minus 20. Push the a's where? To the right, good. So we'll subtract 3a from both sides, which means I'm going to add 20 to both sides. And that gives me negative 1 is less than or equal to 2a. So divide by 2, and I get a is greater than or equal to negative 1/2. Well, let's flip that around. So the way we probably want to write that is a is greater than or equal to negative 1/2. There's my original inequality. So in Desmos, here's what we do. Now pay close attention to this, and I'll put this recording up. Oh darn, something wrong. I'll put this recording up tonight. So if you need to refer to it, you can. Actually, there we go. I'll make it as small as I can. So all we do is we're going to put in what's on the left side, just like before. So I'm putting in my 3 times the quantity 3a minus 7 minus 6a on the left, and on the right I've got 5 times the quantity a minus 4. Okay, here's where you got to kind of pay attention to this. So we're going to try two things. A is greater than or equal to negative 1/2. So negative 1/2 is the endpoint of my interval, right? Agreed? If I were to graph this thing. So when you put in the endpoint of the interval, so when you put in the actual number, even if that weren't equal to, even if this were just a is greater than negative 1/2, so negative 1/2 is not part of the solution. When I put in the endpoint, the value of the endpoint, I should get the same number on both sides of the inequality. So I should still get the same number on the left and the right. And doesn't that make sense? Because what if this had just been an equal sign all the way through, right? I would have gotten the answer a equals negative 1/2, and we could have checked it by plugging in negative 1/2 and getting the same thing on both sides. That's still true. So we'll still do that. If I put in the value a equals negative 1/2, look what happens. I do get the same thing back on the left and the right. Everybody see that? Okay, I'm going to take a picture of that. That's important. Okay, but the other thing we do then, the other thing we're going to do is we're going to check a value in the solution. So if we want values greater than or equal to negative 1/2, somebody think of a value of a greater than negative 1/2. Okay, positive 1/2. So I could choose positive 1/2. And now we got to see if this makes sense. Okay, I get on the left side, I get negative 39/2, and on the right side, I get negative 35/2. Is that a true statement? On the left, I would get negative 39/2. Is that less than or equal to negative 35/2? Let's pick an easier value. Let's not pick a fraction. Let's just pick something so we get similar or simpler numbers. Let's just pick, how about 0? 0 is greater than negative 1/2, isn't it? So I get negative 21 on the left and negative 20 on the right. Is that true? Is negative 21 less than or equal to negative 20? It is, right? So that works. Everybody see that? So the endpoint worked. We got the same number back on both sides. And when I picked a number other than the endpoint, it gave me a true statement. And so that is the solution. Okay? Gabe, get rid of that, please. You shouldn't have that in. I'm not going to ask you that again. I have to do that sometimes. It's the last day I won't have to ask you. Okay, so there's my two. That proves that my two values I picked, it proved that worked. Okay. So we can probably, well, okay, let's try. Gosh, I want to let you work, but I feel like if I skip some of these, you're not going to know how to deal with these, how to check these. I think it's important that you can. So what are the steps to isolate x here? Subtract 6, good. So we'll subtract 6 all the way through. So those go away. I get negative 55. You guys tell me if I'm making a mistake. Negative 10x and negative 50. Okay, now what? Good, divide by -10. And that's gonna cancel the -10. So I get an x in the middle, I get positive 55 over 10. What can I reduce that to? 5 goes into both the top and the bottom. So 5 goes into 55, say it again. 11, there you go, I heard 11 halves. And over here, I'm just gonna get positive 5. What do I have to do? Gotta flip the signs, don't I? And so that's a little bit of a goofy answer. What would I have to do to that answer? Turn it around, so I get the smaller number on the left. So I get my 5 down there, my x in the middle, and my 11 halves. And what's my relationship? Well, x is greater than or equal to 5, and x is less than 11 halves. So there's my solution. Now let's check that in the original inequalities. Okay, so what's going to happen? Watch what happens here when I plug in the endpoints of my interval, 5 and 11 halves. What do you think should happen when I plug those in? What's your intuition tell you about this? So let's plug it. So 6 minus 10x is what I'm plugging it into. Right? And if I plug in the value x equals 5, I get negative 44. Okay? So that makes sense. I got one of the two endpoints when I plugged in 5. What's going to happen when I plug in 11 halves? I get the other endpoint, negative 49, right? So the only other thing to do is to check a value between 5 and 11 halves. 11 halves is just 5.5, isn't it? Everybody agree? So I could check a value like maybe 5.25. That's in between. When I check that, I get a value of negative 46.5. Is that greater than negative 49 and less than or equal to negative 44? Yeah, it's in the middle, isn't it? Right? So everybody see that? It works. Okay? All right. And the last one, I tell you what, I won't do this, but you can probably anticipate how it's going to work. I'm going to end up getting a compound inequality at the end. And, I don't know, you want to see this one?
No.
You really don't want it? You'd rather work? Okay, I tell you what, start working. I'm going to do it real quick, and you can start working if you want to, though. It won't hurt my feelings. Anybody wants to see it, I'll do it real quick. Okay, so real quick, if you're following me here, if you're not, it's okay. Just, you can work if you want to. I'm going to add 3 to both parts to isolate the absolute value. I'll divide each side by 2. And now I isolated the absolute value, negative 2x minus 4. And so I'm going to set up and or whoever's watching. And, good. Because I've got an isolated absolute value less than a number, so it's going to be and. Because in the middle is going to be greater than the negative and less than the positive. So I'll add 4. I get negative 2x, negative 8, 16. I'll divide by negative 2, so I have to flip the signs. And I get my solution. I get x, 4, negative 8. I gotta flip those around, so I'll rewrite it. X is greater than negative 8 and x is less than positive 4. So here's the part I want to show you. If I check that, so there's what I'm checking. So I'll plug in the left side. 2 times the absolute value of negative 2x minus 4 minus 3. And if I plug in negative 8, whoops, x equals negative 8, what do you know? I get negative 8. Or I get 21, sorry, right, which is what I want. 21 is what's on the right side. It works. If I plug in 4, the other endpoint, I also get 21, so it works. Now let's check out a value in between, like 0. If I plug in 0, I get 5, which is less than 21. So the left side does everything it's supposed to do. The two endpoints work, and when I take an in-between value, it makes a true statement. So I did it right. Okay? That's a lot. Okay. Work. Well, you don't have much time to work. You get all day tomorrow to work.